Today we're going to learn another test on how to determine if a series converges or not. This one is called the alternating series test, and in all of the series tests that we have examined so far, except for the geometric, we've only dealt with series that have positive terms. What about expressions that contain both positive and negative terms? They are called alternating series if the signs alternate from positive and negative. So let's look at one particular series here. So if you look at this particular series, first of all, notice this is a geometric because you have something raised to the nth power. And if you list out the first couple terms, notice that the signs alternate from positive to negative. So this is also called an alternating series. Now, I can tell right away that this is a geometric, so r is equal to -1/2, and the absolute value of that is less than 1, so it will converge because it is a geometric series, and that's fine. Another way to do this problem is if you don't recognize it's a geometric, or possibly you have a series that's alternating, but it's not a geometric series. There is something called the alternating series test, and two conditions have to be true. When you look at the limit of the general term, it has to be true that it has to be going to 0. So those numbers have to be getting smaller, and it has to be true the n plus first term has to be less than the nth term. Again, all that means is the next term over, which is your n plus first term, has to be less than the previous term. So let's look at this problem right here, and let's say, okay, this is an alternating series, but notice it is not a geometric series. You are not multiplying by the same number every single time. So let's check our two conditions. So you're going to take the limit of the general term. When you take the limit, you take the limit of the term without the -1 piece. So don't worry about the -1, the alternating sign. So the limit of 1/n is equal to 0. So the first condition is true. Is it true that the n plus first term, so if the general term is 1/n, the n plus first term is just 1/n plus 1. You plug in n plus 1 wherever there is an n. Is that less than 1/n? And basically, if you add plus 1 to any number on the bottom of the fraction is bigger, but the whole fraction is smaller. So yes, this is true. If both conditions are true, you can conclude that it converges. So let's look at the next series. Again, I see an alternating series because I see that -1 to the nth. You do not have to necessarily list out the terms, but here are the first couple terms. So I'm going to check, are the two conditions true? And this test only works if you have an alternating series. So the first condition, I always check the limit first. Is it true that the limit of the general term without the -1 piece, this limit is 1/2. It's not equal to 0, so I can say it diverges. I do not even need to check the second conditions. Both conditions have to be true. Okay, this example down here, so some of these series, there's more than one way to do it. Let's use the alternating series test because I see that there's this -1 to the nth, so it is an alternating series. So I'm going to use the alternating series test, which I will call AST for short, and let's check the general conditions. Two conditions. Is it true that the limit of the general term without the -1, is it equal to 0? Yes, it is. I have to check the second condition. Is it true that the n plus first term, is that less than or equal to 1/2 to the n? Yes, it is, because if you understand this is really the same as this, multiplying a number on the bottom makes the bottom of the fraction bigger, which makes the whole fraction smaller. So this is true for every value of n from n equals 1 to infinity. So yes, I can say this converges by the alternating series test. Now this problem you can do a different way. If you notice, this is also a geometric series. So if you recognize that first and identify that r is -1/2, absolute value of that is less than 1, then you can say it converges. So there's two different ways to do this problem. Recognizing that it is a geometric is the quickest way, but if you do an alternating series test, you should get the same conclusion. Okay, one last problem. Maybe you might want to pause the video at this point and try it on your own and then come back and check it. So I notice this is an alternating series because I plug in different values for n. It will go from positive to negative. So what are my two conditions? Is it true that the limit of the general term, is that equal to 0? No, it's not. So you're done. I do not need to check the second condition. So you can say it diverges by the alternating series test.